Good morning students. Now we are going to see the demo of DC Shunt Motor. So due to the situation, as we can't brought you here, we are just giving the demo of DC Shunt Motor. As you know that already people have studied shunt motor in your theory part. Now let us see. Actually this is one of the motor which is available in our lab. The rating has been given here. Okay, so you can see through it. Then this is the lab setup where you will be doing the lab experiment. Okay, so this is what the starter. The internal structure, I hope we have explained you in the previous video, so I think I don't want to give a brief explanation about the starter. Now coming to the circuit, if you take a DC shunt generator, we know the shunt motor or a shunt machine, we know very well that it has two winding. One is field winding and other one is armature winding, just to give supply to the motor. As we know, during starting period it draws more current, will be provided via starter. So the three terminal of the starter, it has been given here, L, F and then A. Okay, so we know that there are two different windings are there. One is armature winding and other one is field winding. All the winding will be placed inside this particular board. Okay, and for means we can, if you want to see, we can open and see that. And then just to take the connection, here they are given 4 terminal. This Z and double Z represents the field winding, A and double A represents the armature winding. So as per the connection of the DC shunt motor, both the winding has to be connected in parallel. Okay, and this is nothing but a switch. So whenever this is turned on, this is DC supply will be given to the starter, and by adjusting the handle, what happens, that circuit will be closed once we are closing the DC breaker. And then once upon making the connection, what happens, the power will be given to the DC shunt motor, and then DC shunt motor will starts to rotate. Okay, so if you want to see the machine, so here you can find the DC shunt motor. Okay, so mechanically speaking, we have to load the machine. So in the laboratory setup, we can't go with the conventional pumping load or any other load. So in that case, this is nothing but a spring balance which acts as a mechanical load to the DC motor. And here is nothing but breakdown. Generally, when we are performing load test, what happens, the DC motor, it may get heat due to the mechanical loading what we are going to provide. So just to avoid that particular problem, always it is advisable for us to pour some water inside the brake drum. And these are the two spring balance, okay, in which we can able to note down the reading. So by adjusting this particular spring balance, we can load. Okay, so that if we are keep on increasing, okay, what happens, the spring will be overloaded, the needle will tends to move as per the load what we are going to connect. Okay, so everything as like that. Even you can see, whenever I am just trying to tight this particular spring balance, what happens, you see the needle it tends to move. So as like that, we can able to apply mechanical load to the brake drum, okay, until the machine reaches the rated current. On any cost, we should not overload the machine beyond the rated current. So it is advisable for us to take all the before doing the experiment, we have to know what is the rating of the machine. Only then we can able to do the experiment. Okay. So after finishing all the experiment, we have to release the spring balance. Thereafter only the supply needs to be switched off. Okay. Thank you, students.